Hello once again, class, and welcome to our video lecture about the introductory concepts of functions in programming. In this video, you will hopefully learn about some of the existing built-in functions in Java, and also more importantly, how we can create our own custom functions and use it in our own programmatic problem solving. Functions are also known as subroutines. A subroutine consists of instructions for performing some tasks bundled or chunked together. A subroutine is sometimes said to be a black box because you can't see what's inside of it, or to be more precise, you usually don't want to see inside it because then you would have to deal with all the complexity that the subroutine is meant to hide. As an analogy, let's take for example the cockpit in a modern car. A car has so much mechanics and physics involved in its overall system, which allows it to transport us from point A to point B. Here we can see there are a lot of small pieces of knobs, levers, wheels, and buttons to control every aspect of the car. Each one of these controls perform a specific function. The steering wheel, for example, controls the direction of the front tire, thereby controlling the direction of the car as it runs. The clutch pedal performs the clutch function, which temporarily detaches the engine power from the drivetrain, allowing for changes in gears. The gear shift, which allows the driver to change gears depending on driving conditions, and many other functions that a driver utilizes in the overall operation of the car. On the driver's perspective, he didn't have to know the exact mechanics of how each of these controls work from behind the scene. All that he needs to know is what these controls do. This concept can be described as a black box. One of the main reasons for having these controls is so that the operation of a car would be much more easier than it should have been. Without these controls, it would be very difficult to drive a car. Similarly, functions are like this. Programmers create functions to perform a smaller set of tasks with a given set of parameters, or sometimes no parameters at all. And these functions can be performed over and over again. The user of the function do not need to know exactly how these functions work, just how to use it and what it is for. With the use of functions, programs which are otherwise very complex can be subdivided into smaller parts or subroutines, which will make it easier to create, manage, and debug when errors occur. Here are some of the common built-in Java functions. Most of these functions are written inside of what are known as libraries. There are hundreds of libraries available in Java. One of these libraries is the math library, which has the function random and round, and many other mathematical functions, which we can use and utilize anytime we want it. Another class library is the system class, which allows us to output into a screen. And another one is the scanner class, which allows us to grab input from our user. And there are many other library classes which contain several functions which we can use. At this point, let us take a look at some of the built-in functions in Java. So here we are in our Visual Studio Code editor, but before we start writing codes into our program, let me first show you where you can learn all the details about every single functions that are available built into Java. You simply go to a browser and search for, in my case, I am using version 11, so I'll search Java 11 API. In your case, if you're using 15, then you say Java 15 API. and then it will show you the result. The first one would usually be the docs from oracle.com, which is the owner of Java programming language. And somewhere down below the list, there is a link for classes. And if you click on that, it is going to show you the documentation of Java, showing all the list of classes that are built into the Java language. Here you have a lot of classes, and some of them are interfaces. And for example, the class library that we have used so far in the past was the math class. So if you browse down or scroll down to the letter M part, you can see there is that math class here. And if you click on that, it will show you the details of the math class, that it is found in the java.lang package, which is the base package of the Java programming language. And below that, you will see the method summary, which will list all the methods of the math class. Now, by the way, at this point, since we are not yet in the level of learning in terms of object-oriented programming, we can safely say that method and functions are the same. That is at this point, until the time that we'll be talking about object-oriented programming, which we will do here in our class later on at the later part of this course. But for now, let us just assume that method and functions are the same. So here, when we see method summary, it's just the same as the summary of functions that are available in the math class. And this includes, the first one is the abs, which means the absolute value. So this one is returns the absolute value of a double value. So if you put here a negative double value, it is going to return the absolute value of that, which is not negative nor positive. It's always like that. That's the absolute value. There's also the arc cosine, a cos, arc sine, arctangent. There's also the CBRT, which is the cube root, and ceiling is just rounding up a value, and which has a counterpart also of flooring, which is the rounding down of a value. We will be seeing these functions in action later on, but this is where you can be able to learn the details and all the functions that are available. And this is just the math class, remember? And if you go back, there are plenty of classes around. So if you can imagine, there are thousands of functions available within the Java language that are built into the Java language. Not to mention all the other classes and functions that can be available by importing other packages besides the base package. So this is where you can get information to that. Now let's go back to our Visual Studio Code. But before we write anything into our code, the best way to introduce to you to the use of these built-in functions is by playing with them, writing code, and seeing the result immediately. And we can do that in Java, in the newer versions of Java. I think it's starting Java 9, I believe, that you can use a tool that allows you to execute statements right there and then. All you have to do is open up a terminal. So you can click here, new terminal. And in the terminal, you just type J shell. And by typing J shell, you see you're now in the prompt of the J shell. And from this point forward, everything you write here should be Java statements, and you will see the results immediately. For example, if you assign x as an integer with a value of 10, okay, and press enter, you see that it is echoing that, yeah, you now have a variable x whose value is 10. And if you are going to get the square of that x, okay, you can do system that or display the square. So let's system that out that print line and you just have x times x like that, and you get 100. Okay, so this is where you can play and try out some Java code without writing any program. So we can try out some of the functions here that are found in the math class. So the first one was the absolute value. Suppose we are going to say math.abs and we get the absolute value of 900. Of course, that is going to be still 900. But if you put negative 900, you'll also see the same 900 because it's the absolute value. Another one is the sqrt, which is the square root. So if you say math.sqrt on a value of 25, you get 5. All right. Um, and there's also the cube root. So if you have cbrt, the cube root of 81, you see, is 4.3. Okay, the cube root. Oh, what are cube values here? Let's say the cube root of 100 is 4.6. All right. And how about the ceiling? So if you have a value, let's say float a is equal to 9.12345 f, right? And if you get the ceiling of that, you can say math, that's ceil, and put a inside of it, you get 10. So it is being rounded up, and the counterpart to that is floor, wherein you will be rounding down, right? So from 9.12345, it becomes just 9, while the ceil, the 9 point something, becomes 10. So those are some of the examples of the math functions that are found in the math class. So let's now write a very simple program that uses the math class function, which is the hypotenuse function. So giving a problem, trigonometric problem, we are going to compute for the hypotenuse of a right triangle with given two sides, x and y. So let's have first our import. So as you can see here, scanner is also another class. It's just not the part of the base package. That is why we need to import it, because it's located in the util package. But still, it is a built-in class. So first, let us display enter value for x. So we'll have an x value. That's actually, we'll use double. I think it was double. Let me recheck that one. So I'll go back to the documentation. Under math, let's take a look at hypotenuse. There you go. Hypotenuse uses double, right? So we'll have double for x. It's going to be equal to sc dot next double. And let me just copy this and paste. We now get the y value. And here, we put the y. And now we'll have the double, the hypotenuse is equal to, now we simply have to call math.hypot with value x and y as the parameter. And so this function works by getting the square root of the square of x plus the square of y, which is the formula for the hypotenuse, and this will result in a double value, which will then be assigned to the variable hypotenuse. All right. And now we can display this output. The hypotenuse of the right triangle is, and then we add in the variable. All right. So now let's try and run this program. Suppose we have a right triangle whose x side is 5 units in length and its y side is 6.3 units in length. You get the hypotenuse of the right triangle of 8.04. Okay, so that was just a very simple example of the use of a built-in function in Java. And remember, there are hundreds of classes in the Java programming language, which contains several more functions. And you don't have to learn them all at once. You just learn them when you need them. And when you need them, you can always go to the documentation to find out about all the details. Well, for example, if you think if you have a function that you want to create, before creating that function, try to find out if that function is already created so that you don't have to create it yourself. All you have to do is search for it, and if it does exist, use it right there. Of course, if there are built-in functions in Java, we should also have some custom functions. These are the functions that the programmers, you yourself, are going to write or create for your own purposes, for purposes of having a repetitive task encapsulated into one body, or for purposes of dividing a very big program into smaller parts. Then you can use custom functions to do that. When you write custom functions, you just follow the syntax. First is the access modifier. These are keywords which identifies what type of access you are allowing for this particular function. That will be followed by the return type. So if a function would give out a value at the end of its execution, then what type of value will this give out? However, some functions might not give out any value. In that case, the return type will be void. After the return type, that will be followed by the function name. So in the example of the math class, we have the functions ceil for ceiling, or floor for the flooring round down, or ABS for the absolute value. So in your custom functions, you type the name of that particular function right here. That will be followed by an open parenthesis, and inside of the parenthesis will be the list of parameters. This list of parameters will be the values that you want that will be used in running this particular function. The parameters are separated in comma, and they will be written as if you are declaring a variable. And a function may or may not have parameters. However, if you are going to put multiple parameters in a function, you are going to separate them with a comma. And after that will be the closing parenthesis, and the opening curly bracket will trigger or will signify the start of the body of the program or this particular subroutine. And that is called those are called the statements. And at the end of all those statements that will be executed by this function, you close the function with the closing curly bracket. Here's a very simple example of a custom function. And I see there's a typo there. Sorry about that. So let's take a look at this very simple function. The public static are the keywords that are the access modifiers. The word public simply means that this particular function is accessible by any other classes outside. And static only means that it has its own existence. If you are not familiar with it, or if you are having trouble understanding that, don't bother understanding it at this point. We are going to talk about it in more detail later on in our course. Next is the return type. In this particular example, void is being used as the return type. This means that this particular function does not give out any value after its execution. If, For example, you have a function that gives out a string, then you are going to put string here instead of void. Or if you are, for example, trying to create a function that computes the sum of two integers, then this should be int here. Followed by the function name. Say hello is the function name in this case. And of course, you are supposed to use a name that describes what this function does. Then inside of the parentheses will be the parameters. In this example, there's only one parameter, which is the name parameter, and it is of type string. And within the opening and curly braces will be your statements or the body of the function. Let's try and take a look at how do we define our own custom function and use it in our program. So here we are once again in our Visual Studio Code editor, and this time we are going to remove our previous code, and now we are going to define our own function. The function we are going to create now is a very simple function. Let's first use the function in the example or in the presentation. It was a public static void say hello with a string parameter called name, and what it does is simply display it on the screen with a say hello and the name. So that's how you declare a function. It should be outside of another method. This is the main method. We have here your say hello method. All right. So the main method is what is being executed when you run a program, but within the main method we can call other methods like this. So here inside of our main method we are going to call the say hello method. Let's ask the user to enter a name. Okay, now that we have a name, we can use that name as our parameter to the say hello method. We can just say hello and pass in the name. And when we run this program, all right, it asks what is your name, and if I type Henry, it says hello Henry. Now let's have another function. Let's create a function that performs the task of computing or identifying a year, whether it is a leap year or not. Remember that a year is a leap year if it is divisible by 4. However, if it is divisible by 100, then it should also be divisible by 400. We can have a function to do that. So we have here public static, and since the question of being a leap year or not is a true or false, if it's a leap year, you'll have true. If it's not a leap year, you'll have false. And so the return type here should be Boolean. And in here, the name of our function should be is leap year. And inside, we are going to have a parameter, which is an integer for the year. All right. Now, let's do the coding to identify if this year is indeed leap year. We can do this within one if statement. If year, first let's check if year is divisible by 400. Year percent 400 equals 0, then or year percent 4 equals 0, then we'll say return true. Otherwise, we will return false. Now there's a bug for this code, but we'll get that. We'll get to that later. So now let's change our program here. Instead of asking for the name, we'll be asking for a year. Enter a year. And here we have int year is equal to sc.nextInt. All right. So now we can ask, is leap year year? Again, this particular statement returns true or false. So we can put this inside of an if. If is leap year, then we can display that it is a leap year. So year is a leap year. Otherwise, you'll say year is not a leap year. Let's try running this program. So if we put the 1999 year 1999 is not a leap year. And let's try again. If it is 2000, 2000 is a leap year, right? So there we go. We have created our very own custom function and use it into our program. So that will be all for this lecture. I hope that you have understood a little bit about functions. And what I'm expecting you is to practice and create your own functions and try to look for problems that you can solve and extract the solution into a function so that you can reuse that function over and over again within your program. So that will be all for this lecture, and thank you so much for watching.